see the wall, we will go by define slab. Now we go by the section, wall section. Add P. If you want to make it specified, then see scale thick or thin, then color the wall. So I already defined can image shear wall for the stair and if then specify C13 scale thick, use scale here, and then the color below, and then thickness as same here on it. Okay. Now how I will draw, you have here draw wall floor. Okay, then for by the area you the area of the stair. If you the last version use the this is, then it comes to you for example wall or use shear wall, then I will start this. I already draw it. Okay, this wall you draw it like this, draw or from the roof. I want to go. Okay, some versions, old version used difference, but here you draw line. This is specified from joint to joint. I want it for every floor. Yes. Here is the goal. It for the area if as I if I want normal wall, soil bottom, there is masonry wall, there is concrete wall. Wall or wall quick. Then I will use another wall for the type of material I will complete the C30 like and then I will start drawing the drawing. Then you collect point to the wall. You draw in the area that needs the wall. There is some room that keeps coming from here. You want to draw like we draw the floor plan and the walls, like here. Skip here to close it. Like you draw from internal walls and external walls. External walls. It clicks for me the triangle. Okay. Look. This is for the story 1 to draw the walls. Put it even here, the triangular I collect it. Yeah. I slap. Anyhow, and now I go for the whole row. We'll do that here already. Here, close. Go to the row. We'll do external and the internal as the parts from one more any material define it. Don't close. The slab, the wall. So now we're back, and let's explain now the dead load and live load of the structure, how we can display it on the design after finishing the wall, everything, all the walls, the external and the internal. That's how I show you. Anyhow, while you're designing the loads, you have to also design the earthquake load and the wind, and you have to build depending on that to know the capacity of the structure, so that any natural disaster to resist it, to not fall immediately or easily. So taking care of the earthquake and the wind load, design also the structure. Now we will check step by step. First, open an Excel and write dead load. We will begin by the slab. You have dead load of the slab. And then we will calculate the wall load. So in the first floor, second floor, now the slab is affected by the load of the wall and all the finishing materials that has load. So we have to calculate it. So I need first to calculate the length. Go to the drawing and take specific large area. I choose this area. And then choose the wall and add the length of the wall. This is just an example. You can do each area levicha. Or you can take the majority, the maximum load, and then apply it. On the length of that area, the length of the wall, add the length from each side. I added 4.5 plus 3.5 from this side, and then from that side, also from the middle. So you just take dimension, linear, and then take the length of the wall. And then need the moral. After you finish, it's by meter. After you finish adding the length of the wall, you need to calculate the height of the wall. We will go to this section. The height is 3.4 for the ground floor. Okay, meter. And then we will calculate thickness of the wall. For example, we choose 0.20. This is thickness. Now we will see the density of the wall. For HCB wall, it's known that it's 4 kilonewton per meter cubed. This you can check the manual of the density or any reference tell you, or any test. Kilometer perimeter cubed HCB wall. On the weight, we'll calculate the weight. Which is equal مبازات the length, the height, the thickness, and the density. So the total weight, I got it, kilometer per meter cubed. Okay, now I will take the area. I will go to the area that I took the wall or the partition wall from it, and take the width and the length. See about per meter square. So length is about 3.5 سي بعضها 4.5 meter square. So the load, the total load will be the weight over the area. Now we got the dead load of the wall, HCB wall, kilonewton per meter cubed. Now we will go do another finishing floor. It has a weight. Cement, screed, and ceramic has a weight on the slab. So we have to calculate this dead load. Floor finish. The load. So our it's a mortar for the, or we'll take the ceramic. Ceramic is highest the density. So check the density of each, and then the thickness is 7 cm, which is 0.07 meter. And then the total load, I will say basal, the thickness by the density, or the weight, and the weight. So I got now the weight of the ceramic, kilonewton per meter cubed. I will fix it here, and then my basal. Now we have also the cement screed before the ceramic. Actually, the density Salam, Nacho. We're back. We have here cement screed, and the cement need mortar. The mortar density 3 or higher sost kilometer per meter cubed. Then the thickness 3 cm, which is 0.0 sost. And then the total مبازات, the total load. Actually it's 1:3 ratio, the mortar. And this is the total load or the weight. So we will add the both weight of the cement screed and this ceramic. And the total load. I will add all of them, the total load of the wall, the finishing floor finish, cement screed, and 7 and the live load, as you see for the slab, 4 كيلو نيوتن. And then we will come to the total, the load. We will calculate the load of the beam, dead load of the beam, and we will begin by the wall. So the load applied to the beam is the weight of the wall. We have to calculate it. First, let's say here the live load is 4 kilonewton per meter cubed. If I minus some length of the wall, I take it from one side. I will reduce some little amount of the kilonewton per meter cubed of the dead load. Anyhow, you take the maximum area and then you calculate the load on it of the wall and everything. And then for the beam, I already كفافلكو the buildings from ground floor beam. I have also typical floor beam and roof floor beam. I will arrange them. And then I will say the height of each beam. I will write it. For example, for ground floor it's سوسنة برات, it's equal سوسنة برات, but for the roof it's سوسنة 20, or we will make it the same, سوسنة 40. The height of the wall that stays on the beam, and then the thickness, which is 0.20. It's higher centime for the wall. And then we have also the weight, HCB wall, which is أسرع أرات for all. The density, I mean, of the HCB wall. So the total weight, مبادات, I will multiply the density, the height, the thickness. And this is the total dead load. Kilonewton per meter cubed. And then I will display the load in the design. So first I will say select properties, and for the slab section I will choose, and then I will choose here the solid slab. I will say apply, select. After that I select the section, I will go to the assign, and then load, slab load, or like this, or shell load, uniform, and then I will apply the load here at the end. And this is for the frame, but let us first it was the live load. In the load section I said 4, and then display it. Let's do it again. Okay, 4, like I was assign, I made shell loads, and then I add on the load about 4. This is the live load. Also I have to assign the dead load, and this you change it to live or load or dead. back. So we after we added the dead load, we add the live load, and we see it's look, and change it to live, and the live load was add, and then you say add to existing load. Don't say replace because it will omit the dead load, so we want them, both of them. You will make add the existing load. And then we will change the elevation to C. Now we will go to the beam. So we already entered the slab load. We go to the beam, changing the elevation to C. And then we will go, we say assign frame section, uniform load. First again we have to select the section that will assign the load in. So we will go to the frame, select frame section, and I will choose me from the ground to the second story is typical, so I will say ground floor beam or first floor beam, anyone I will click on it, it will be the same. Now he selected the 3 stories, the ground, story 1, story 2. Now I will assign the load. I will assign the frame section load. I will check the way that comes to me. It's 9.52 for all, for the 3, for the ground floor beam, typical, and roof. I'll say okay. I will add 9.52. Look, it assigns for me the load. And for the roof, I will go assign for the roof. I will say assign frame or section. I will choose first, I will select the roof, and then I will assign the load. I will select now roof floor beam, and then I will assign for it. For example, if it's 2.51, I will add the load 2.51. I will change 9.52 like the others. Now even the roof assigned to me. So the whole will display. I will go to 3D model. We'll change this window to 3D model. I wanted to show all the loads that is applied to the floors sections. Look, all of it. So now we know how much the slab will carry, how much the load the wall will carry, the beam also. It's needed for the construction and choosing the material and everything. This is the 3D. You can arrange the windows, go to the options, do arrange windows, and then it will arrange for you the window 1, window 2, and the other. or you do refresh. Now I will return it back to the plan floor. Anyhow, if you want to do mesh, select some bottom or in the plan, and then or guide lines, and then do analysis, auto mesh and the specific mesh. You choose it, you can do the mesh. This is in the new version. You can clear it without back. There is a PS previous and there is clearing item there in the table down or beside the left table. Like here, you select the section you want and then clear. You can do clear from the beside table or the left table. I will return it to 3D. It's very good practice. That's it for the load. We'll see another maybe earthquake calculation.